This is a picture of a blast furnace. It's about 100 meters high. It's used to obtain iron from iron ore. The name of the ore is called hematite. Iron ore is a rock that only contains about 40% iron oxide. Since this is the amount of iron oxide present, the rest must be waste, and that has to be gotten rid of in the next process. This is a piece of hematite, iron oxide in rock. The hematite is added to the blast furnace at the top, along with coke, which makes it into iron. The limestone is added to get rid of the waste, so it has to be added even though it isn't used to make iron. The main reaction is with iron oxide here and carbon monoxide to produce iron and carbon dioxide. The carbon monoxide comes from this reaction here. Coke and carbon dioxide form carbon monoxide, and this is the main reducing agent for this reaction. In summary, the carbon monoxide, here it is again, reduces iron oxide. It grabs the oxygens to turn into carbon dioxide, leaving iron behind. Iron oxide is reduced to form the product. The temperature inside the furnace should be around about 1600 degrees C, and that allows the molten iron to trickle to the bottom and collect. The waste product, that's the slag here, is what's left over from the hematite earlier. There was only 40% iron oxide. The remainder gets removed as slag. Molten iron comes out at the bottom because it's the densest material. And the hot air must be mentioned because that's the thing that sets up the temperature inside the furnace and gets the reaction going. You may remember heating copper oxide with carbon in a lab in a test tube. To get copper, it's quite difficult to see the copper. Both copper oxide and carbon are black powders, and to see a little bit of copper powder in amongst all that black powder is quite difficult in the end. Once again, the copper oxide loses its oxygen, so we say it's reduced. All these reactions which involve the use of carbon to take oxygen away from a metal oxide are called reduction reactions. The metal oxide is reduced. If carbon is going to reduce the metal oxide, then the metal compound must be below carbon in the list. So carbon is here. We have zinc oxide, iron oxide, copper oxide. They're all reduced with carbon. These metals are too reactive, and so carbon can't be used to make the metal. We have to use a different process. And this process is called electrolysis, and we'll talk about it later on.